Good morning students, I am Padmaja MSc B.Ed, your new chemistry teacher. Today we are going to learn about few basic concepts that you will need for the first chapter. The universe consists of matter and radiation. What is matter? The air we breathe, the food we eat, plants, animals, stones, clouds, stars, even a small drop of water or a particle of sun, everything is matter. So we can define matter, things which have mass and occupy space. Radiation, you know very well, the rays of the sun, light emitted by the stars. So the universe consists of matter and radiation. What the matter is made up of? Elements, compounds and mixtures. What are elements? The basic form of matter that cannot be broken down into simpler substances by chemical reaction is called element. What are compounds then? Two or more different elements chemically combined with one another in a fixed proportion by weight. What are mixtures? A mixture is a material made up of two or more different substances which are physically combined. Now let me give some examples. Elements, the hydrogen, oxygen, chlorine, the metals like magnesium, aluminium, copper, silver, gold, these are all some examples for elements. Compounds, water, carbon dioxide, nitrogen dioxide, ammonia, methane, these are all some examples for compounds. Mixtures, now we are mixing a spoonful of salt or sugar in water. It forms sugar solution. So that's a example for mixture. Now what these elements, compounds and mixtures are made of? Atoms and molecules. So atom is the smallest particle of element that takes part in the chemical reaction. Group of atoms we call it as molecule. Now let's check if you know few elements that we come across in our daily lives. Are you ready for the quiz? First one, what do you think is the essential element needed for respiration? Oxygen. Good. Second one, do you know the element present in clinical thermometer? Mercury is the only metal in liquid form. Third one, what are the two major elements present in our bones? Calcium and phosphorus. Fourth one, what is the element present in your lead pencil? It's not lead. It's graphite, one of the allotrope of carbon. The last one, which element is used in packing of medicines and food materials? Yes, you are right. It's aluminium. Now let's learn what these elements are made of. That's an atom. Now look at the structure of an atom. Structure of an atom. The nucleus is the central part of the atom. It contains protons and neutrons. Proton is a particle with positive charge that is in the nucleus of an atom. An uncharged elementary particle that has mass nearly equal to that of proton and is present in all known atomic nuclei except the hydrogen nucleus is neutron. So protons and neutrons are called nucleons that is present inside the nucleus. An electron is a negatively charged subatomic particle that orbits around the nucleus. Now let's learn little more about the atom. The number of protons in an atom remains the same for each element, whereas the electrons that orbits around the nucleus takes part in chemical bonding or reaction. Now, number of protons in the nucleus of an atom is termed as its atomic number. Number of protons and neutrons in the nucleus of an atom is termed as its atomic mass. Now, how we represent the elements? Using short method. The shortest representation of an element is symbols. It may be single letter, two letters or letters derived from their Latin names. For example, the symbol of hydrogen is H. Helium is He. Here, first letter should be always capital letter. Second letter should always be small letter. Hydrogen, boron, carbon, nitrogen, oxygen are some elements represented with single letter. Helium, lithium, beryllium, neon, magnesium are some elements represented with two letters. Sodium and potassium is represented in their Latin words natrium and kalium with the symbols Na and K for potassium. For some elements, first two letters from their names used as symbols. Helium He, beryllium Be. For some other elements like magnesium, first letter and third letter Mg is used as symbol for magnesium. Now, can you identify the element with atomic number 3? It's lithium. Now, yet another example. For an element, the atomic mass is 11 and its atomic number is 5. How will you find the number of protons and neutrons? Since the atomic number is 5, number of protons also 5. Its atomic mass is 11, so number of protons and neutrons together is 11. Now you know protons are 5, so the number of neutrons is equal to 11 minus 5, that is 6. So neutrons are 6. The element is boron. This is how we have to find out protons and neutrons from the atomic number and atomic mass. So you are clear with the elements and their symbols, its atomic number and atomic mass. Now let's see how electrons are arranged in different shells. Before writing the electronic configuration of elements, let us see the classification of elements. You know very well, element is a basic form of matter which cannot be broken down into simpler substances by the chemical reactions. Elements are all made up of same kind of atoms. Thus, for 118 elements have been discovered. Each element is unique and has its own fascinating properties. All of the 118 elements were arranged in a table called modern periodic table. The elements are classified into metals, non-metals, metalloids and radioactive elements. Now let's look how these elements are placed in the modern periodic table. This is the modern periodic table of the elements. 7 horizontal rows are called periods and 18 vertical columns are called groups. Now let us discuss about the 18 groups. Hydrogen is given isolated position though it is in first group. The first group elements given in red are called alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. Second group elements are called alkaline earth metals, that is beryllium, magnesium, calcium, strontium, barium and radium. First and second group represent the S block elements. Now the 13th group starts with boron, its boron family. 14th group is the carbon family. 15th group is the nitrogen family called nitrogens. 16th group is the oxygen family called chalcogens. 17th group starts with fluorine and it is called halogens. 18th group starts with helium, is called noble gases. Group 13 to 18 represent P block elements. Now on your left are the metals, on your right are the non-metals. On the zigzag line highlighted in yellow are the metalloids. Now I hope you have understood how the elements are arranged in the periodic table. Now let's learn about electronic configuration, also called the electronic structure. It's nothing but the arrangement of electrons in energy levels or shells around the nucleus. The first shell is K shell, which accommodates maximum of 2 electrons. Second shell is L shell, which accommodates maximum of 8 electrons. Third shell is the M shell, which accommodates maximum of 18 electrons. And the fourth shell is N shell, that accommodates maximum of 32 electrons. Let's see how the electrons are arranged in different shells for various elements. For example, hydrogen has 1 electron in K shell, that is first shell. Helium has 2 electrons in K shell or the first shell. Lithium has total of 3 electrons, that is distributed in K and L shells, that is first and second shells. First shell accommodates the maximum of 2 electrons and the third electron is accommodated in the second shell. Now take a look at the electronic configuration of neon, which has total of 10 electrons. First shell accommodates 2 electrons and second shell accommodates 8 electrons. Now let's look at the electronic configuration of sodium, which has total of 11 electrons. First shell accommodates 2 electrons, second shell accommodates the maximum of 8 electrons, so the remaining 1 electron is accommodated in the third shell, that is M shell.